The sun has always been a source of warmth, comfort, and light. But we're discovering a new and frightening side to our star. A kind of solar rage peaks every 11 years. And sometimes, Earth is in the line of fire.
It's 1 billion tons of matter traveling at 1,000,000 miles an hour.
A solar blast could send us scrambling. Without warning, navigation systems could be disrupted, blinding jets in the sky. Phone connections around the world could go dead, leaving us stranded during emergencies. And within minutes of impact, a power blackout could leave millions of people in the dark. In a land of ice and snow, the sun sets life into motion, bringing precious warmth and light to our planet. Without the sun's energy, life would quickly vanish from the surface of the Earth. When the Arctic sun finally sets, it may not rise again for months. A dark chill is cast over the land. Here, the Inuit people have long taken their cues from nature to survive the harsh winter months. They use the northern lights to guide their way in the darkest times of year. They believe the sky forms a dome above their heads, and their ancestors dwell on the other side. The shimmering lights are heavenly torches held by spirits as they play in the skies above. They are beacons to guide the souls of the newly dead. Perhaps there is a wisdom in the stories of these old men. Perhaps our lives are more profoundly tied to the heavens than we know. We understand now, as we voyage into space, that the ribbons of light are caused by the sun. Today, scientists are taking a closer look at our neighborhood star, and its disposition is not altogether sunny. An erratic sphere of superheated gas, the sun is 15 million degrees hot at its core. Powered by nuclear fusion, our raging sun is an ongoing H-bomb, equivalent to megatons going off every second. And yet, it is somehow easy to take for granted.
People go out in the street, they look up and they think, big ball of fire in the sky. It doesn't change, very constant, always there. But when you look at it, you realize it's just a big mass of gas that's forever in turmoil, forever churning up, always spewing out things into the interplanetary medium. It's just a great thing to study. You never know what's going to happen tomorrow with it.
What we want to do is understand this stuff. I mean, we don't just looking at it because it's pretty. We want to understand what's going on, and we want to be able to predict things because it does impact us on Earth.
The sun has the potential of disrupting us in ways that we haven't understood before, just because we are a more wired, connected, interconnected world. A disruption could potentially, in certain places and in certain technologies, be rather serious.
Our star is the only star that directly affects our planet. And yet the sun remains an elusive and distant frontier, beckoning us to take a closer look.
One thing I like about observing the sun is that it's this tangible disk. You can see it, you can feel it. Unlike other stars that present themselves only as a tiny spot, the sun, although it is a star, is up close to us. You can see its personalities, if you will, and you can plot these unlike most other stars.
Larry Webster has been studying our daylight star for 22 years. His work carries on a long scientific tradition of recording the faces of our ever-changing sun. High above the Los Angeles basin, Mount Wilson Solar Observatory is an ideal place for watching the sun. At the 150-foot solar tower, a century-old ritual is about to take place.
Okay, what I'm doing is adjusting the coelostat so that the reflection of...
Larry Webster has been studying our daylight star for 22 years. His work carries on a long scientific tradition of recording the faces of our ever-changing sun. High above the Los Angeles basin, Mount Wilson Solar Observatory is an ideal place for watching the sun. At the 150-foot solar tower, a century-old ritual is about to take place.
Okay, what I'm doing is adjusting the coelostat so that the reflection of the sun comes off the first mirror into the second mirror, and then that redirects it down to the objective lens. And it's actually the lens that forms the image of the sun in the room below.
The ancients call the sun a most pure and lucid body, but Larry Webster sees instead a surface covered with blemishes, sunspots. He begins each fair day by sketching the face of the sun. No two portraits are alike.
To the casual observer on the street, the sun might be just this unchanging hot disk in the sky. But to the astronomer, it's a disk that has a lot of features on it that can be observed. Like today we have these sunspots, and to the solar astronomer, that's a very strong magnetic field right there.
The sun's magnetic fields are spawned by invisible forces beneath its surface. Where the field is most intense, sunspots tend to form. Often several times larger than Earth, these blemishes can last as long as 4 months.
Sunspots are the physical manifestation of magnetic fields on the sun. They're cooler by about 1,000 degrees, and so when you see a sunspot, it's darker against the surrounding photosphere because of that. And then the magnetic fields might come out, loop around, and come back into a adjoining spot next to it.
The sun's magnetic forces are constantly changing. Its field lines twist and knot with the sun's rotation. Over an 11-year cycle, these magnetic lines become more and more tangled, breaking the surface to create sunspots. At solar max, the peak of the sunspot cycle, the sun is coiled and ready to strike.
Professionally, I study the sun to carry on the tradition of solar observing. We don't know everything there is to know about the sun. Any changes in the sun's output can affect the Earth dramatically. And so we continue with the record keeping.